first we are going to hand it over to Courtney, who is going to start us off by sharing some information about a long-term monitoring and citizen science project studying beluga whales.
Yeah, thank you so much for having me. My name is Courtney Shuert. I am a conservation programs manager with Assiniboine Park Conservancy in Winnipeg, Canada. If you don't know where that is, it's in the exact middle of Canada, probably the farthest from every ocean in Canada that you can get. Um, but I'm here to talk about our project called Beluga Bits. So this project's been ongoing since 2016. Every year, for those of you that aren't familiar with beluga whales, every year in the Churchill River estuary, which is in northern Manitoba, we see about 55,000 beluga that gather in and around the estuary in the Western Hudson Bay population. And this population is really unique in that we see that they are quite interested in boats. They really like to engage with people in the estuary. So we use that to our advantage. And for the last 10 years or so, we've been live streaming with our partners at Polar Bears International and Explore.org to an underwater camera in the summer. So unfortunately, this is the last week I think that the underwater camera is running. So, hurry and get out and try to watch that live stream this week if you can. But we use this to do some really cool science. So the Beluga Bits project happens in three sort of big steps. So first we have what we call photo capture stage. So folks tuning into that explore.org live stream can actually take snapshots for us of, interesting things that they see on the camera. We take all of those for our data. We also take all of that video footage that we gather over the summer and split that video footage into images. We then take that over, truck it over to our computers here in Winnipeg. And we use a machine learning program to drop empty frames because looking at empty water is pretty boring. And then we upload all of those photos to be classified on Zooniverse. So we have a Zooniverse project called Beluga Bits, where anybody can join in and help us classify images. And then we use all of those classified images to understand things from a research perspective. So we look at things like behavior, age classes, presence of calves, sex ratios, distinguishing features, and so on. So for those that aren't familiar with how Zooniverse works, typically we have what we call workflows that help us extract data from static images. So right now we have a project called Beluga Backs on, where we're looking for unique markings on the backs of whales. Typically we only see whales at the surface, so we're looking for those unique features that we could see maybe above water. We're also looking at ages and stages, so trying to identify in the images, which ones are adults, which ones are juveniles, subadults, etc. We have a new workflow on right now to try to understand skin conditions in beluga whales. So it's called Spot, Specks, and Streaks, and that is hopefully going to help us to understand and be able to track health in beluga whales. And then we also look at other species like jellyfish. So we have another workflow too called Is That a Jellyfish, which is actually pretty fun. And as of last week, we had almost 35,000 volunteers on this website. So hopefully we'll have a little bit more after this talk because it's a lot of fun. And often we get photos that look a lot like this. This is really nice. It's really great when you can get full whales, lots of interactions, but sometimes you only get, a snapshot of a tail, super close up, not really a whole lot of context necessarily or group interactions, sometimes just part of a back, sometimes a little bit of nightmare fuel when they actually try to bite the camera. So right now we've been working on using 360-degree videos to track behavior underwater. So right now we use the Insta360 X4 with just their proprietary dive case and a selfie stick from the boat. We're also working on developing a mooring type deployment that could be left unattended. But obviously this gives us a literal greater depth of observation. So you can see this side by side of above and below water. We're able to track individuals pretty deep and be able to see kind of what they get up to. And as you can hopefully hear with the sound, we can hopefully pair that with some of the acoustics that get picked up by these cameras. Some of the challenges that we have is that it's shooting in 8K resolution, which is really great for science communication and that sort of thing, but obviously is a huge amount of information. It's also marrying in that gyroscopic information from the camera. So there's software with Insta360. I might just turn this down a little bit so I'm not shouting at you. Um, that has some tracking capabilities, but it doesn't really appear to work well with whales. You can see that their contrast ratio changes quite a bit depending on how far away they are. But we'd really like to be able to follow individuals and extract that information without that labor-intensive manual video editing that we have to do right now. So my questions for Wild Labs are, are there options available for translating that 360 video into flat images or series of images or videos that maybe is a little bit easier? Are there ways that we could track individuals in a shot to focus on for footage? Are there, more advanced sort of computer vision approaches that might work in a 360 environment? And, just really generally have others found ways to tackle this problem? So that's my speed talk for you. I'll take any questions and then I'll just leave this cute little link that goes to our Zooniverse project if you'd like to join along. And we also have an Instagram account, so be sure to follow along. So yeah.
Thank you so much for that. That tooth photo is crazy and will be haunting me for quite some time. We have definitely some time for questions or ideas or whatever insights people might have if anyone wants to throw it in the chat. So I'll give that just a second for people to think about anything. And if not, I have a question for you, which is less about the 360 footage, but more about from the static images and sort of the flat images that you guys were collecting before the 360 camera. What sort of like insights were like extrapolated from any of that, if there was anything on like individual, like specific individuals or group behavior or whatnot?
Yeah, so what we're sort of in that like critical mass stage where we're starting to write up a lot of that data. So what we're hopefully going to be able to see, because we have that 10 years of data, to be able to look at changes over time. So this area is in it's in an area with a port, and this port is currently slated to begin expansion for Canadian shipping throughout the Arctic. So we're really hoping that we can kind of provide that baseline data for things like, skin conditions, scarring patterns, things like that, so that we can provide that sort of baseline before port expansion sort of starts. Because as we've probably learned from elsewhere in the world, that sometimes human development can have negative impacts on marine mammals, especially. So yeah, we're sort of at a cool point with that. Some of the unexpected things that we learned is with the jellyfish side of things is that we actually had one of the northernmost records of a certain type of comb jelly that hadn't been detected in that area before. And that was purely based on some sort of citizen scientists that had kind of identified these jellies and had been like, oh, that shouldn't be here, and then kind of became a thing out of that. So yeah, it's been a really fun ride, learning from folks that we work with online, as well as, kind of our own selfish science perspectives.
Jesus. Well, thank you so much. And again, I encourage anybody that has questions or ideas or direction support to point Courtney and her team into to either reach out to her or do so in the chat. Thank you so much for that talk.